Hello all, welcome to a second day of our virtual GSC conference. So glad that you all got to join us this lovely morning in UK. Today we have a presentation about extending the value of our MQ messages presented by Andrew and Dale. If they don't mind, introduce themselves in a second, that would be preferable. But anyway, enjoy, guys. You are good to crack on. We did agree that the questions, if you guys have any questions throughout, just post them in the chat and we will address them as we go. But yeah, over to you guys. Enjoy.
So, Andy and I are looking at each other, waiting for each other to start. I think I will get started then. Hello, everyone. Thank you very much for coming. My name is Dale. I'm an engineer at IBM. I started life as an MQ developer, and now I work on Kafka. So I've sort of seen both sides of that world, and I'm joined by my colleague, Andy.
Yeah, hi, I'm Andy Borley. I'm technical lead on the IBM Event Streams product. I've been in IBM for 20 odd years now, and yeah, done lots of things in that time. And the most recent has been playing with Kafka.
Right, let's get going.
So yeah, so today we're talking about event-driven architectures, and that's about handling and reacting to events as they happen in your business. So events occur in a continuous stream as things happen, and if you can take advantage of the continuous stream, then your applications can react and can reason about the future based on what happened in the past. So things, for example, you could detect abandoned baskets in your web channel and use that moment to interact with a potential client, or you can maybe eliminate some of your loading times by getting data to your APIs before it's required and making APIs more responsive and the end user experience more delightful. And you could potentially bring context to machine learning models, so making real-time recommendations that can continuously evolve as the situation changes. Next slide, please, Dale. So yeah, so the components, what are the components of an event streaming application? So the first part is the event sources. So this is potentially sensors or web traffic, thinking back to those abandoned baskets, or maybe data in an existing database, or it's what we're going to talk about today, a set of messages that are flowing through your MQ system. The next part would be your stream processing handler, the ability to process streams of data in real time for analytics or machine learning. And then once you've dealt with those messages, you might want to store them. So you'd have an event archive to store the events for some future reference. And you may want to trigger notifications as well, so that those who need to know can be made aware of what's going on, what's happening. Live as it happens. And that's all connected by the event backbone.
So a lot of this kind of stuff around an event backbone, decoupling applications, we use terms like topics and publish and subscribe. This is going to be sounding familiar to you as people who are used to MQ. So it's worth taking a quick moment to talk about how they differ, because they offer different styles of messaging. They're both a form of messaging, they're both middleware in some ways, but they have their own unique roles to play in your architecture. With message queuing, you're typically sending a command. You're sending a message and you know who the recipient is. You know who the target of that message is. You're typically instructing something to do something. You often want to reply. You often want to know when that command has been carried out. MQ messages are often valuable, important. Reliability is key. You need to be assured that that message will get there. Event streaming is slightly different, because an event typically isn't a command telling someone to do something. An event is recording that something has happened. It's a log, a distributed log. It's a way of recording an event that has occurred. So it brings with it different characteristics. So for example, for that log of events that have occurred, you want history. You want to be able to go back and see what happened yesterday or a week ago or a month ago. So it's not like MQ where you take something off a queue and then you're finished with it. You no longer need it, you know, transient. With an event on an event backbone, you need typically to be able to go back and see that history. And because of the way you process an event, you want to know that it isn't going to change once you've processed it. So you don't have to keep going back and looking at old events again. So that idea of this as an immutable log, an immutable record of things that have occurred, brings with it different application patterns. So these are the kinds of properties that we found people are looking for when they're building event-driven applications for that event backbone that Andy was describing. The technology we're going to be talking about, often kind of the de facto standard in this space, is Apache Kafka. Open source, distributed streaming platform, supports publishing and subscribing to streams of events, storing it in a way that is durable, but allowing that real-time processing for the kinds of analytics and sort of machine learning stuff that Andy was describing. So that's kind of the background. That's kind of where the stuff we're going to be talking about sits. But for really the rest of what we want to spend our time talking about the session is how you can bring these two worlds together. And we've got some demos we want to show you, and we want to show you actually how you get all of this set up. So we'll start with a diagram just to show you big picture before we dive into the details. So as we said, actually going back to this diagram Andy was showing, what we're talking about is this step one. You've got a queue manager, you've got queues, you've got messages on those queues. What we want to show you is how you can use that as one of your event sources, and how you can surface those messages onto the event backbone so you can do all these other things. You can do stream processing in real time on them, so you can push out notifications to a load of apps. So that's kind of where we're sitting. We're talking about how we can use MQ, playing that role at the start of the process. So you've got a queue. You've got an application that's putting messages on the queue, and you've got another application that is getting the messages off the queue. We don't want to disrupt that. We don't want to mess with that. We don't want to do anything that would impact the application that is getting those critical messages. So the first thing we're going to do is use a feature that was added recently in MQ. I think it's a year or so ago, called streaming queues. I've got some sort of MQSE script on the side here, but I'll show you it in the UI in a moment as well. But what you do is you create a copy queue, and you set the config of this original queue to say that every message that hits this queue, you want a copy to be streamed to this queue. That means you can be sure that everything that has gone through that queue and has been consumed off by this application at the bottom, a record, a copy of all of those messages will be available on this copy queue for some additional alternate processing. And we're going to use this copy as the source of our flowing into Kafka in a moment. One quick thing to point out is this streaming queue quality of service. You can choose the quality of service you need for that copy. What we're using here is must duplicate. In other words, treat that put and the copy as a single atomic operation. So either they'll both work or they'll both fail. With this quality of service, you can be sure that the two queues have an exact one-to-one match to each other. If you aren't so worried about that, you can choose, like best effort as a quality of service. But for our purposes, because we want an exact copy of everything that was on the MQ queue to be flowing to Kafka, we're choosing that must duplicate quality of service. So with that tiny bit of config, what we've now got, without disrupting that original application flow, without disrupting the putter or the getter, they will carry on working as they are with no code changes needed. With this bit of MQ config change, we've now got a copy that we can start flowing into Kafka.
So yeah, so on the Kafka side, so Kafka, if you're new to Kafka, you have multiple Kafka brokers which are running as separate instances, and within Kafka brokers, the data is held in topics. And when setting up your Kafka topics, there's various considerations that you need to think of. And three of the major factors are your retention, so how long you're going to keep those messages for, and that's bounded either by a time or by the total storage size of the messages in the topic. There's replicas, so how many copies of the messages you want to keep for high availability purposes, and that's those will be spread across the separate Kafka brokers. And then there's partitions, which is about how the data can be split up for scalable consumption. So each partition guarantees the order of messages going into that partition, and by default, the messages are pushed into those partitions based on the keys that you're giving the messages as we go along. So we'll show some examples of that in a minute. So if we go on to the next slide, please, Dale. And then to get the data from MQ into Kafka, the architected framework that Kafka provides is called Kafka Connect. And this allows you to stream data to and from Kafka. And here we have the MQ source connector running on Kafka Connect, reading the messages from the MQ queue and then writing the data into the Kafka topic. And like Kafka itself, Kafka Connect is designed to scale, and it does this by running multiple tasks for each connector across a distributed set of Kafka Connect worker nodes. And as well as MQ source, there's lots of different connectors that exist, and you can ingest from all kinds of sources, databases, Elasticsearch, cloud storage, Redis, HTTP, and so on and so forth. And so it's likely that your data source has a connector already, and if it doesn't, you can always write your own, because there's interfaces, and it's pretty simple to get started writing your own connectors for Kafka Connect. So if we go next slide. And now that your MQ data is in your Kafka topic, it can be read by multiple consumers and scaling that up as you require going forward. So
that's the idea. Let's switch to a demo. Let's hope that the demo gods are on our side. So here is the MQ UI. I'm going to start with this. So let's put a message here. I'm going to imaginatively go with hello world. So now this message is on the queue, and to just check that, I can get that, I've got a little JMS app that's going to get the message off the queue and print it out with the JMS header. So you can see there my hello world. And now if I refresh the queue, my queue is empty. So that's kind of my existing setup. I can put messages onto my MQ queue, I can get them off. But in the background, I've got that connector that Andy was describing running. So here is my Kafka topic, just load the page. And you can see that message I just put. You can see the timestamp is just now, that hello world. If I just put another one quickly, another message, that goes on there and it flows through. If I just refresh that. Come on, there we go. And that's my other message. So that's kind of the basics of what we want to show you. What's running under the covers is a connector, which does take a bit of setting up. So what we're going to do is walk you through how to configure it and some of the decisions you need to make when you're configuring a connector, so that you know how to do this for yourself, so you know what the choices you've got available to you are. So with that, oops, sorry, Andy, I'll hand over to you.
Oh, yep. So we've just showed a message flowing through from MQ into Kafka, and it's gone through the MQ source connector as we've gone along. So as Dale said, we're going to show you some of these details. So let's look into the main components you can configure in the MQ source connector. And the first one is the record builder, and this is specific to the MQ connector, MQ source connector. And it's used to build the Kafka Connect record from the MQ message that has been pulled in. So if we go on to the next slide. So the connector supports lots of different types of MQ and JMS messages that you define using this the record builder. And it's also extensible via this pretty simple interface. So if your message type isn't currently supported, you could write your own record builder and import it, use it with the connector so that it can handle your messages.
And we'll show you how the default record builder is good for most use cases. But if you're doing, if there are particular headers, RFH2 headers, or anything in your MQMD that you're particularly interested in surfacing in Kafka, this interface is here, so you can pick out just the bits that you're interested in. But like we'll show you, the default one is good enough, nearly all use cases I've seen.
So we've retrieved the message from MQ, built the Kafka Connect source record. So the next step, and this is an optional step, is to use the Kafka Connect single message transforms. So these are built into Kafka Connect themselves, come from Kafka, and they can modify the message in simple ways as it flows through the connector, such as adding or updating, moving, deleting fields, all kinds of things you can do. And
the most common use. Oh, sorry, Andy. The most common use we see of this is like redacting. So if there's sensitive data in your MQ messages and you want to get the bulk of it into Kafka for processing and analytics and real-time notifications and all that good stuff, but maybe there's some little bits in those messages that are sensitive and you don't want surfacing to the Kafka developers, these transforms are a really neat, simple way of just masking out those sensitive bits of data. And we'll show you an example of that in a moment.
And again, there are a variety of transforms that are in the box, but you can write your own if you want to. If there's something specific you want to do when you're handling your message, you can implement this interface from Kafka. And single message transforms, they're supposed to be small and quick and stateless. They're not for things like calling out to disk or making HTTP calls, because that would slow down your stream quite a bit. And yeah, you wouldn't want to do that. They're for fast, simple transformation. And so we've retrieved the message from MQ, we've built the Kafka Connect source record and then transformed it. And then the final step is to convert the source record to the serialized bytes that will get written to Kafka. So this can depend on the kind of format that you want the bytes to be in on disk on Kafka. But again, if we go to the next, there's a set of converters that Kafka provides, or again, you can write your own. And so yeah, so Kafka is only interested in a byte array that's going onto disk. It doesn't mind, and it doesn't care what the information is. But obviously you do, so you can use the converter to make it in the form of bytes that you want to later be able to read out. So there's the three configurable steps in the MQ source connector: building the Kafka Connect source record from the message that's come from MQ, transforming it, and then converting the record to the serialized bytes that get stored in Kafka. So now we're going to show you some examples of how you'd configure these three sections to make it real.
One nice thing quickly, I just thought, one thing I like about this is it's composable, right? It means that the MQ Kafka record builder doesn't need to know how to do lots of different transformations or support all the different types of formats you might want. Because the Kafka Connect is this sort of pluggable thing, there are converters for any type of serialization technology you can think of, you know, protobuf, Avro, JSON, XML, whatever it is that you want. So the MQ bit, the MQ record builder, doesn't need to know how to write to XML or write to JSON. All it needs to do is return a standard form, and then you can plug in any of the Kafka Connect converters. And the same with transforms as well. It gives you this composable plug and play from a variety of sources. But let's show you, because like I say, it means you've got a lot of choice. You can choose what bits to compose. So we want to make that a bit real by showing you some examples. So let's start with a simple one. So you've got an MQ message, normal vanilla MQ message with some byte array, some bytes in that message. So as I was saying before, when you're choosing a record builder, the default record builder, and I've put the value there in case for people who use these slides to get started for themselves later, it's good enough for most things, and it's certainly good enough to just move some bytes around. By default, it's JMS is false, but just to be explicit, what you're configuring here is to say that this isn't a JMS message. That helps the connector know how to get the message off the queue in the right way. For Kafka Connect to do some of the downstream things, it needs to know what the data is. So it will fill in that this is an optional field and that it describes the shape of the data, which is bytes. But otherwise, it just copies the value from the MQ message into the Kafka Connect record. Transforms, they're optional. So for now, we'll keep it simple. We won't do any transforms. We'll just skip that step. We just want the message as is from MQ into Kafka. So for the converter, because we want the bytes from the MQ message to appear as bytes on the Kafka topic, The converter we're going to pick is the byte array converter. And again, I've put the full class name in there for anyone who wants to use this as a reference. The result of doing that is, unsurprisingly, you get a Kafka message with the bytes across. So that's kind of like the simplest use case. You can go from the default record builder and the byte array converter, and that will just get you a like-for-like copy of whatever byte. So if there's some sort of like custom proprietary message format that you've got that isn't necessarily a string, if you've got some binary data that you're using MQ for, and you just want to get that binary data into Kafka, this is your quick and easy way of making that happen. Let's go to a slightly more interesting use case, though. Andy, I'll let you take this one.
Sure. So the next use case, this time we've got a JMS text message containing some textual string data, and you want that to turn up in your Kafka queue, Kafka topic as some string data again. So again, we're going to use the default record builder here. There's the class name for it, but there's an extra minor bit of configuration here where we're setting the MQ message body JMS property to true, which tells the default record builder that it's a JMS message, and it's got and so it can handle that data in particular ways. And so again, we're not going to transform this message. We just want to get that text, that string data from MQ and into Kafka. So we're going to use the string converter from Kafka. There's the class again to convert that string into bytes, and that's standard Java strings, so that would be UTF-8 bytes that are getting put into Kafka, so it just looks like a typical string. So again, that's another really simple use case. We're using the default record builder with the JMS body property set to true to read JMS text messages and spit out Kafka records with the as a string, as a standard Java string.
And I think just to switch back, so this is what you saw me do when I was demoing earlier. I had the value converter to string, and I was using the default record builder, and I was setting JMS to true. But let's do a more interesting use case. Still JMS, but this time let's go back to bytes. But what I want to show here is there are other things in an MQ message besides just the payloads, just the data. So this time we'll set some headers, we'll set some properties. Again, the default record builder is fine, so that will get the bytes across. But to configure it, if I want to bring those JMS properties across to the Kafka world, I set that MQ JMS properties copy to Kafka headers, lovely named property, to true. And because Kafka messages have keys are used to help group and arrange the consumption in the event backbone side. So you can choose if you want to add a key to your Kafka messages, what value it should use. So here I'm saying that I want to use the JMS destination header as my key. So that copies that across. So that's all the config I need. Headers, it's not just going to be those custom properties that you set. All of the properties that you get by default by your JMS client library, like the app ID and the user ID and the timestamps and all of that stuff, all of that will get flowed across as well when you say that you want to copy your JMS properties. So all of those JMS properties that maybe are useful and relevant for processing, if you want to bring them across to the Kafka world as well, that's the setting you need to set. Again, we won't do any transforms for now. We'll save that to Andy's run through next. So to convert it, because this is a byte array, I'm going to use that byte array converter again. So what I'm going to end up with is a Kafka message with a key that came from my JMS destination ID, a whole bunch of headers, including my custom ones, but all of those default properties as well. And the data will be copied across as an array of bytes. So that's worth keeping in mind. It's not just about the payload. If there's useful data in your headers and properties, you can bring them over as well.
Okay, and then our fourth example here. This time we got a JMS text message, and the data is actually in JSON format there. So you can see there's a greeting field and a count field. The other point to note is that there's a header, the JMS correlation ID header that we're going to use as well. So we're going to use the JSON record builder this time. So that will actually pull in the data, read it out, knowing that it's going to be in JSON format, and put it into an internal serialized, a deserialized form within the connector that can be used with the transforms. So what we have, the other point to note is that we're using a MQ record builder key header here to say this is the key that I'm using. This is the header I'm using to get the key that I'm going to store in Kafka for my message. As I mentioned earlier, partitions are one of the ways in which Kafka allows you to scale up the consumption of data from Kafka, and it uses keys by default to set which partition a message will go into. So if messages have the same key, they will end up in the same partition, and they will stay in the order within that partition within Kafka. So it's a useful thing to think about your keys and know what they are. And you can, in this case, we're using a JMS correlation ID to make sure all the messages with that correlation ID will end up in the same partition and in order on your Kafka topic. So the next part, we're going to talk about the transforms. So in this case, this example, we've got 3 different transforms that we're using to make changes to the message as it flows through. We've got a redact, we've got a rename, and an insert. So the redact is using the mask field transform, and in particular, we're telling it to use the value part of the message to mask part of it. So we're just looking at the value of the message, because you can do the same thing on the keys as well if you'd like to. But in this case, we're using the value. We're looking at the greeting field. So maybe there's some secret password data or something in that field, something that you don't want to end up in the Kafka side of your business, that is flowing through the MQ side. So in this case, we're going to redact the greeting field. And then we've got a rename transform, and that's using the replace field transform class. Again, you're looking at the value side rather than the key side of the message. And then we're going to rename the field count to the count. And then finally, we're going to insert some static data using the insert field transform. And that's going to add a field called origin and a value of MQ, so that when we're using the messages on from the Kafka topic, we know that this is a message that's come from MQ. So once those have happened, we can see what the Kafka Connect source record looks like after it's been through those 3 quick transforms. Our greeting field has been emptied out because that's been redacted. Our count field has been changed to the count, although the value has stayed the same. And then we've added an extra field in. And there's all sorts of other things you can do for transforms. As we were talking about before, yeah, there's lots of different things that can be done.
And as Andy was pointing out before, you know, if the whole set of out-of-the-box transforms doesn't do exactly what you need, you can write your own. The Java interface is really simple. It's basically you get an object in, you make your changes, and you put it out. So this list is comma separated. You can just keep adding more ones. You can get as complex and rich as you want. And the out-of-the-box ones covers really most use cases. But if there's some unique transformation you need, you're always free to write your own Java class to do that.
Yep. And then we're going to use the string converter to convert the JSON representation that's in the MQ source record there into string JSON string JSON notation. So that will just sit as a string essentially in your Kafka record when you put it out onto the Kafka topic. So that was a slightly more complex example where we've used we've taken a JMS text message and we've picked up that JMS correlation ID header and used that as our Kafka record key. And then we've used the mask field, replace field, and insert field transformers to alter the message as it's flowed through. And then we're using the string converter to put it out as JSON onto the Kafka topic. So that's the full list of transforms we've got here. So yeah, we've showed the 4 different demos using the record builder to pull the data in and transform it into the Kafka record that we're using. From MQ, we've used transforms to transform the data, and then the converter to convert from the Kafka source record into the bytes that actually go onto the Kafka topic. And so it's as we've shown, it's pretty easy to connect IBM MQ to Apache Kafka. We've shown the source connector, and there's the link there. It's all open source. You can go and pull the code down and build it yourself, or you can pick up the jars and build them into your Kafka Connect to run these things. But there's also the sync connector, which goes the other way. So if you've got data on your Kafka topic and you want to put it into MQ, the source and sync notation is from Kafka's point of view. So the source is a Kafka, it's a source for Kafka, and it's a sync from Kafka. But yeah, so you can go either way, and we're copying messages from the MQ queues to the event streams topics and vice versa. And it supports all the current MQ versions and platforms, and it's easily extensible. So if you've got any business-specific message format you're interested in doing, you can extend the connector using those interfaces that we mentioned before. And it's fully supported by IBM with support people who paid for IBM event streams.
So I want to talk a little bit just quickly about where you might run this, how you might run this, where it lives in your architecture. So Kafka Connect is a Java application. So the simplest, smallest, quickest way is you can just run it anywhere you can run Java. Now, typically we run it in a containerized way. So it fits nicely in a containerized world, whether or not you're just running containers or you're doing it with orchestration in Kubernetes. The way I typically use it is in a Kubernetes deployment. So you can have sort of multiple replicas, scaling up, automatic restarts, all of that good stuff. So, because like Andy was saying at the start, Kafka Connect is a distributed system. You can run it in a mode where you have multiple workers that coordinate with each other and distribute the work around them. They have, it's a quite nice way of being able to dynamically scale this up. So what happens is that Java application, the connector is going to make by default, a client connection to your MQ queue manager, and then it's going to use the Kafka protocol to talk to the event, to the Kafka topic. So for the source connector, which is what we've been showing you for most of today, it's going to be that top blue one going left to right. So a client connection doing gets from MQ, and then it's doing Kafka produces to your Kafka topic. But as Andy was saying, we do have a connector that goes in reverse, so you can just reverse that. There is a question about where do you put it physically, and you can put it either side. You can put it next to your queue manager, you can put it next to your Kafka cluster. Both are fine, both will work. If you're really pushing a lot through it, if performance is a key consideration, then typically you'll put it next to the queue manager, because if you compare the two protocols, the MQ protocol is a bit more chatty than the Kafka protocol, which is a bit more driven around batching. So for optimum performance, you might want to sort of co-locate the Kafka Connect worker next to your queue manager. But really, for most workloads, you're free to put it in either location. One particular reason that might cause you to put it next to the queue manager, though, is if you don't want to have a client connection, if you want to make a bindings connection to your queue manager. Now, most typically, we see that with people running MQ on Z, where either for security reasons or cost reasons, they don't want to expose a client connection to the queue manager. If that makes sense to you, then you can run Kafka Connect in the USS. There is a tiny bit of extra config that we haven't covered, essentially to do that episodic conversion for when it's retrieved into Kafka Connect. But other than that extra field, it's essentially the same as what we've been showing you. And the benefit of doing this way is it's a much more efficient connection to your queue manager because it's using that bindings connection instead of a client con. And this is kind of like the grand vision, the picture of what we want to describe. This idea that using the events that you've already got in your MQ queues to enable a whole load of new types of applications that the Kafka consumption model supports, enabling you to build those real-time apps, those responsive apps, those dynamic apps, maybe those analytics and machine learning apps that can take benefit of the ability to replay the old history, to do that sort of analysis and analytics. But that it's not going to interrupt or disrupt or affect your existing MQ applications, because that streaming queue config allows you to sort of pipe off a copy of the messages for flowing into Kafka. And so here we've got just a couple of slightly salesy slides for IBM Event Streams, which is our IBM's fully supported Apache Kafka offering. And we've got Apache Kafka sitting there, and we've built a bunch of useful stuff on top of it. So we've got that UI that Dale used to show you the messages as they were coming in. It's all built on Kubernetes, so you can use powerful ops tooling. You can do the declarative model to set things up. We have a schema registry, which allows you to define schemas for your messages, so that you know the structure of the messages as you're going through. We've got a set of connectors that we have tested out and support. The MQ ones are amongst them, and of course we've got IBM support, which is always there to help you when and if you need it. So there's two different ways in which you can get IBM Event Streams from IBM. There's the self-managed software. We're part of Cloud Pak for integration, where you can get a license for Cloud Pak for integration, and that gives you access to all of the various integration products from IBM. So that includes MQ and Event Streams. So you may already have access to Event Streams via that. And there's also the fully managed cloud service, so you can leave the management of Kafka to us and run your own Kafka Connects if you want to be able to put the data into your own into Kafka on cloud. And these are built, if you want to get started, on some there's the Strimzi open source project, which is what the Event Streams on-premises product is built on top of, and that allows you to run Kafka in the OpenShift Kubernetes environment. And then there's the Lite plan on IBM Cloud for Event Streams, which is a very free service which allows you to use IBM. Use Kafka without starting a big bill. So yeah, there's a link there for getting started, and yeah, come and join us. Enjoy Kafka. Yeah, I think it's really important that we point that out, that you can try this out for free, whether you're running it yourself, as Andy says, or if you want to try it as a hosted service, we offer that too. But even if you're running Kafka, your own Kafka, you're running the open source Apache Kafka, everything we've shown you, the connectors, and Andy showed you where the GitHub repos for the connectors are, you can go and get them. Kafka Connect is free and open source. Our connectors are open source. So everything that we've shown you, you can try out for yourself for free. So we don't want to get too salesy. If you would like help getting started though, you may have heard of Client Engineering. It's a team that is available as a free resource to our clients to help them try out things like this, try out new POCs. Some of our colleagues did a talk about this yesterday, about some of the projects that they've helped customers do in containerizing and bringing MQ into sort of a containerized world. So if you missed that, then I think the recording should be available. But yeah, if you'd like us to help you get started with joining up Kafka and MQ and building some interesting new things around that, we'd be happy to give you a hand. And like I say, this team is available as a free resource to all IBM customers. So with that, we have fortunately left some time for questions. So what we've tried to show is event-driven architectures enable a whole class of new applications, and there's a whole new set of tooling around it to enable responsive, event-driven real-time applications. But MQ can play a really nice part with that. What we've tried to show you is how easy it is to join up MQ so your existing queues can be surfaced, and the messages on those existing MQ queues can really easily surface as events on an event backbone that you can then start doing sort of new processing with. And we've shown you the kinds of ways to set that up, the kinds of transformations and filtering and converting and things that are possible to do with that. And with that, has anyone got any questions?
I can't see any questions in the chat. If everyone should be able to unmute themselves if they want to ask anything in person. Everyone really shy by the looks of it.
We obviously explained it so well.
Yeah. Let's see. RC just messaged in the chat. RC, do you want to maybe unmute yourself if you have a question?
Yeah, hi. Can you hear me?
Yeah.
Yeah. So it's just near the beginning of the slide you had where you had a copy of a queue going to another queue, and that was then basically driving off to Kafka. That indicated it was a local queue. I was just intrigued. Do you have it as a queue remote as well? So because typically stuff might be going further downstream, but I was just thinking if you had a copy of that at the beginning of the stream, and that journey could then go to Kafka as well as the other journey go in to wherever it might be going, whether it's to an external party or another app or what have you. So
I'll be honest, I am not sure. I have always done it with local queues before. I would have to look that up, I'm afraid. Sorry. You've asked the gotcha question that tripped us out.
Sorry about that.
I mean, just instinctively, my assumption would be, and like I say, I would need to look it up, but particularly when you're using the must duplicate quality of service, my assumption is it would be local because it's all done within the same transaction boundary. But I'm not sure. I would have to check.
Okay. And presumably the local queue, you'd have to do a get when you're doing that source. You wouldn't want to do a browse because obviously that would then fill up, but presumably there would be an option to do a browse, would it, if you wanted to?
So if you ignore the Kafka Connect side of things for the moment, if you've just set up streaming queues, then yes, you would have just another copy of a local queue that you could browse. But when you're running the connector, the Kafka Connect is destructively getting all the messages from that queue. So as long as the connector is keeping up, that queue will be empty, that copy queue.
Right, okay.
And that's why we use a streaming queue for this instead of pointing Kafka Connect at the actual original queue, because otherwise it would get in the way of whatever applications you've currently got. Streaming queues, because we've had Kafka Connect for quite a while, but the new feature of streaming queues really made this much, much easier, because before what we always used to have to do is set up dedicated queues just for Kafka Connect and then handle that upstream with apps putting to it. But now streaming queues allows us to make that copy that Kafka Connect can be free to drain as much as it wants without getting in the way of any existing apps.
Okay, so another quick question.
There are use cases for streaming queues. It's worth pointing out, although it's ideal for us in the Kafka world, streaming queues is worth having a look at just as a feature in its own right. If you want to be able to take that split, that fork, and process the same stream of messages in two different ways from two different places.
Okay, and just another quick question then. So in terms of the performance, you sort of indicated it wasn't too much. So if there's a huge volume of messages going through, adding this on it would be negligible in terms of the performance, or would there be a slight noticeable hit if it was very high volumes of traffic?
From the MQ side, it's another JMS application doing JMS gets, so it's not zero, but it's not particularly heavyweight.
Right. Okay. Thank you.
We do use commit and rollback, so there is some transactional overhead, but it's been worked on over time to try and do that in as efficient a way as possible.
Anyone else? I have allowed, apologies, I haven't allowed people unmute before, but everyone can unmute themselves now. So if anyone has any other questions, feel free to shoot. And if no one speaks up, then Dale, could we go back to the first slide where people can see your and Andrew's email address? If anyone has any questions, hopefully they can reach out directly. It would be just good to see if anyone wants to take a note of names.
Just noticed we forgot to put our email addresses on the slide.
It's all right. It's part of your agenda entry, actually. So if anyone wants to find, as long as they know your names, they should be fine. So hopefully. So yeah.
And please do reach out. We'd be happy to help if anyone has any questions, either on the MQ side or the Kafka side. I mean, like I said at the start, personally, I've been on both sides of the fence because I used to work in MQ and now I work in Kafka. But so I definitely see synergies. I think they work together really, really nicely, and the two messaging styles complement each other really well. They both have strengths in different areas. So I do think that between the two of them combined, they allow quite a nice rounded picture.
Brilliant. Right. If no one else, again, thank you very much for the presentation. Thank you everyone who attended. It was really good. Enjoyed it a lot. So thank you very much. And we shall see you shortly. Thank you very much.
Thank you very much.
Bye. Bye, guys.